All right, we left off on Friday talking about a different Andrew investing in Jimothy's bank, and it made me feel really uneasy, but I didn't say anything at the very end. I was like, that number makes sense, I guess, because you're increasing, like, you're tripling the money every 10 years, and that seems right. But then I realized, you're not tripling your money, you're increasing by 5%. How are you going to even come close to tripling your money? And then I realized, oh yeah, we have, our answer, our formula is a little bit incomplete, because what we were assuming was this. We were assuming that we had 100% interest rate, which means if I come over here, this number was 1, but that's not 1 in this case. In this case, it's 5. It's 0.05 as a decimal. So in order to account for that, I need to not have 1, but change it into an R and see what would happen. And it's actually not that much harder. I mean, the old formula used to be e to the power of t, like it's 12 years, you plug in 12 for t and call it good. The new formula just has a slight twist to that, which is this. It's going to be e to the power of t times r. Cool, there's a fix, and now everything's ready to go.
What's R again?
R is the rate, your interest rate. So in this case, in our last problem, what did we say? It was going to be 5%, so R in our new problem is going to be 0.05. So I need to modify this last problem so it's not 100% interest rate, because Jimothy learned his lesson. So we need to change this. This number is way too big, so we're going to go ahead and erase you. Gone.
But then
gone,
where's
gone.
n?
N is the number of times that you compound it. So it's one of those things where I can't really prove this without using calculus, but we kind of saw that this was getting closer and closer to E if you plug it into a table. N disappears. I have to do some like hand-wavy math because we're not in calculus and I can't prove it to you rigorously, but it was the way that we made this N in the bottom smaller and smaller and smaller. Sorry, bigger and bigger and bigger, right? You want like not 12 times, not 100 times. How many times are you compounding? It's the number of times that you compound. And both of those ends are competing against each other, and then they pop out an E somehow. Again, I feel bad that I have to do hand-wavy math. We don't have the rigorous tools that calculus unfortunately provides. Coming back here, that means I need to modify our formula up here. This is not T, but it's T times R. So there's the new addition, which means this is not 10, it's 10 times this 5% is going to come down here for our R. And we're going to say that this is R, let's turn it into a point, so it's going to be times 0.05. And then I can plug it into the calculator. So let's go ahead and pull up our calculator. There's our calculator. There's me practicing over the weekend, making sure that it made sense to me. All right, so if I type this in correctly, I have $10,999, and this is going to be times this letter E. This is going to be raised to the power of, and then I need parentheses, so they're just going to jump down. So it's going to be 10 times 0.05, and that seems much more reasonable with 5% interest rate. So I'm going to come over here and write out. It's going to be 18,000, which is only slightly. It's not even double after 10 years. $18,134.29. Cool. I'm gonna do one more example and think that we can skip into classroom from there. All right, example 2.
Can you explain what the difference is between the equation we did on Friday versus this one? Because I thought we were already putting the R there.
So our equation from Friday said just do e to the power of t. How long is it? It didn't account for any change in interest rate.
Oh,
We assumed that r was 1, so it was going to be t times 1, but the interest rate is not 1 anymore. In that last case, it was 0.05.
okay.
Yep. Good question, good question. Again, I still have to do hand-wavy math, which makes me feel bad, but let's try another one. Who wants to invest?
That's what?
Who wants to invest? Okay, Giorgio.
I'll invest.
I don't invest, I just want to.
Wow.
Giorgio launders.
Launder.
How much money can you launder, Giorgio?
Like a realistic amount?
Sure.
I got $500 to my name.
10 million.
I was gonna be like, he's got 5 cents. We'll see how much that can increase.
I have $500.
And you don't really get an interest rate when you launder. You kind of have a return on that.
It's not really.
Well, doesn't it decrease then? I want things to increase, and when you launder money, you lose money.
Yeah,
But like,
in some way. And you were in,
I have to go back to,
When
sorry,
you-
it can't be
lo-
longer.
laundering
I
money
want
is
this
just-
to increase so that it's preparing you for what's gonna be on the quiz test and homework checks.
isn't laundering money just cleaning the money that you get from
And Bitcoin.
investing like?
Yeah, but you lose money along the way, yeah. You have to lose money along the way, it's impossible. to
But really, you're
perfectly-
investing in like the legal part of it, not the laundering part of it.
Yeah, so you can invest the laundered money, but
Yeah.
to launder the money, if the verb is to launder, then you're going to lose money in the problem. So
Or
Giorgio,
invest in Bitcoin. I think
Invest in
invest
Bitcoin.
$500
Are we talking 3 years ago, or are we talking right now?
of
8
clean
years
money.
ago.
How did it clean? Maybe it was clean to begin with, we're not gonna ask any questions.
Don't
Of
ask
clean money.
questions.
Don't worry about it.
Definitely not clean.
What are you gonna invest in? Are you gonna invest in like a mutual fund, or are you gonna go like stock market, like 10%, or are you gonna go like, I don't know, silver? How much is silver gonna increase? It's close to
Invest in
7%.
Tesla.
What are you gonna invest in?
I'll invest in stocks.
Nissan.
So if you're doing stocks, it averages about 10%. At 10%.
Yeah,
annual
Nissan
rate.
sounds like a good one to.
Interest
14%.
rate. I
Actually, I
can,
wonder if Nissan right now is a good
Um,
investment.
when do you think you'll
Well,
need that money?
regard.
Do you think you'll need that money in 1 year, 2 years? 1 year will make the problem too easy, so can we go 2 or more? How
I
much,
was
how
gonna say a
long?
month, but.
A month? I mean, that would be a fun problem, but it's not
No,
gonna be
that's
similar to one that
complicated.
you can do.
I'm gonna say 2 years when I grad. Okay, yeah, 2 years. When I start college.
Just act like you're a sophomore. It's 2 years.
I need the money for when I go to college.
We're gonna be graduating in less than 2 years.
Yes.
I know.
How much money will he
Basically-
have?
I think you're gonna be graduating in
3 months.
Like 3 months, yes.
And
Yeah, just
no,
for
I feel like I
like,
kinda just
not even
feel
a
like
semester, a quarter.
Oh, wait.
A quarter.
We can
Oh
make
my
this problem
God.
much more interesting, much more similar to the homework. We can go backwards.
Sorry.
For show.
Leaving you out of
Let's
there.
go backwards.
You have
Yeah,
no
guys.
homework and you haven't
Was it
even
you who was
addressed
all
it?
this?
But
I'm gonna say an amount.
Yeah.
We don't know how much money he invested. He's not gonna tell anyone, because it might be not clean. It might be, I don't know.
Or it could have been like
But
inside
we
jokes.
will know that the interest rate is 10%. We'll ask the question, how much money did he have? If he ends with, I don't know, how much money you wanna end with, Giorgio?
Preferably like 20 grand.
20 grand.
Specifically 20 grand. 20 grand and a 1 at the end.
No.
Okay, maybe
No,
that's
no,
too
no,
good.
no, no.
He is making the, does this say Alden on this, or does this say Giorgio?
They called you out.
You get a problem in the future, don't worry.
This is our
And
last
30
one before
cent
the
though.
homework.
Joking. Don't put the 30 cents.
Okay.
Don't.
Is it 20,000 on the
God.
You want a fraction cent as well? No.
No, first. That's messed up.
What about taxes?
We'll worry about
Don't
taxes.
even add that in right now.
Alright,
Oh my
so
God.
the way that I would solve this problem is I'd just kind of plug into our formula. So again, the formula that you're always thinking about, you're thinking, okay, my final amount is equal to my start amount times e to the power of RT. That's you're doing this over and over again. So his final amount was $20,001.30. And that's gonna be equal to a start, which we don't know, so we'll make that, I don't like S because it looks like a 5. I'm gonna do an S.
Or if it, I mean, I don't know, I
P.
just usually do X for like everything.
P, because that stands for
Never mind.
principal, because principal is the actual word that you're supposed to start your money with. Times e to the power of, do we know R in this problem?
Great.
Yes.
What is it?
10, is it 10%?
It is 10%, which is, as a decimal is going to be,
Oh,
0.01.
0.1.
yeah, 0.1. And then how long was that in there for? That's gonna be times, how many years?
2.
Yeah, so this 2 is gonna come down here. We'll say this is gonna be 0.1 times 2. And we can solve for P or solve for X. Solve for the variable, right?
Why is like 8.3% 0.083, but 10% is 0.1?
You just move the decimal place twice. So for example, if I had 10% versus 8.3%, right?
Because 8 is lower
How do we
than
get 10 how do we get
just changed
10%?
it.
she was asking just about decimal placement, like how do you convert
Oh,
this
cause
to
you're
this?
moving it twice, never mind.
Yep, so 1, 2, 1, 2, so one of them ends up as a 0.1, one of them ends as a 0.083.
Oh.
How did we get
She-
put 10%? Where did 10%?
10%, I made that up from the problem, cause you said you wanna invest in the stock market.
Oh, yeah,
Historically,
okay,
the
that
stock
makes
market
sense.
returns at about 10%. It can be lower some years, higher some years, negative some years, which is really, or not negative, yeah, negative some years. You lose money the entire year, which is really sad. You waited a whole year and you got what? Less money.
Nothing.
You have to
Yeah,
pay-
worse
you have
than
to-
nothing,
You have to
less
pay the money.
You had to pay the stock market, right?
Well, they may say that I lost money, but in reality, I just put it in the washing machine, if you catch my question.
Right, so I'm gonna, on my calculator, I'm gonna type in e to the power of do I need to do the power of? The power of, in parentheses, 0.1 times 2. So I know that this number is about 1.22, and I still have the $20,001.30 over here. So I need to get p by itself, and it's being multiplied by 1.22. What are we gonna do?
Pre-algebra, what happened in pre-algebra?
We divide
You
by
took
one
that
point two
one.
two. Very good, very good. You guys are all awake on this Monday. 1.22. And again, I'm gonna keep my numbers exact. I'm never gonna round until the very end. It's just a good practice to have. So P is gonna be equal to, I'm gonna type in 20,000 and 001.3. So that's my number, and I'm gonna divide it, I'm not gonna type in a number, I'm just gonna type in answer. So it takes the previous answer, plugs it in here, and it tells me that Giorgio was supposed to start with $16,375 and about 68 cents. Is this a problem? Alright. Who wants their own problem? I'm realizing that there are really hard things that we can do.
I do.
Yeah, okay. We'll let Alden weigh in because she, I think, is probably feeling like she's
I
left
was
out.
gonna say something, but I didn't wanna speak on behalf of her.
Um,
I'm not her husband.
Yeah.
She's not.
I was gonna say I was the boss of Giorgio, but I think that would be like I knew his
Well-
business, I knew it was up, I could report it to the police.
So
but-
George is spoken for by.
so Emma invests.
He's spoken for by Jessa.
Whoa.
Alden, you get to choose how much she invests, how about that? And then Emma, you can choose how much money you get out.
Okay.
Or, no, I'll let you choose something. Emma, how much is Emma gonna invest, Alden? How rich is Emma today?
He's asking you.
Let me get big money.
Why'd you look at?
Like
I
one
told
got
you
$100.
that you're not spoken.
Emma
for.
invests $100.
Emma, you got big money? No.
You got
Not
more
big-
than
not
me.
big- not
She
big
doesn't
money.
know how to do
What?
her laundry is what.
You got more money than me and you're.
We're gonna go for, Emma, what return do you want? Do you want like 7%? You want 8%? You want 50%? What do you want?
So big.
No, 50%? I have no idea how you're doing that. I'm not gonna ask questions. After it gets above 15%, it's illegal and I don't wanna ask. At 50%
I did mine.
for T years. AKA, we don't know this.
I know.
We don't know how long.
Can I ask a question?
Yep, and now you can ask the second one.
You do this every day.
Well, some people say, I have a question, and then I can't say that.
I have a question.
Okay?
Is every single time you're doing this, you're just solving for X?
Yeah.
No.
Some of them are gonna require different tools. The last two tools were really easy. You plugged in the first case and you're done. You plugged in and moved something around in the second case. This case is gonna be really hard. This is like a truly tricky question.
If you say, can I ask a question, isn't that the question? Is that what you're implying?
Right? Yeah. It's like the equivalent of like a person that rubs the lamp, gets a genie, he's like, I wish I knew what to wish for. Okay, that counts as a question.
Yeah, that's-
That counts as a wish. Emma, how much money do you get at the very end? It might be 80 years, it might be 1,000 years. How long? Well, we're gonna figure out how long, but you need to tell me what is the final amount of money that you get.
30 million.
$100 put in, how much money comes out?
3 million.
It's, yeah.
3 million? Yeah, alright, let's do it. Alright.
Well, we don't know the time.
Sure.
She collects $3 million at the end of T years.
That's gonna take a very long time.
How long did
No.
you wait?
To get 3 million?
I don't know. With 50% with 50% returns.
Well, it's gonna take years. Many years.
So again,
No.
every single one of these problems you solve the same way. You use the form. It's a plug and chug. It makes me feel guilty. There's a lot of math that we had to do to get to this point where we can just give an equation, plug it in, and then just solve for x. Do you want to make it x this time, Chloe, or do you want to make it t? T is usually time.
I don't know, any single problem that's either just X and Y, cause I don't know, it's just easy for me, but.
Because the formula essentially is n is equal to start times e to the power of, what do you say, time times rate, tr. I don't know what variables we're using, but something that means time, something that means interest rate. And there's a t in start. So we know how much we end with. We end with 3 with a bunch of zeros. 1, 2, 3, 4, 5, 6 zeros. And then we know that our start is going to be 1 with 2 zeros. We know this is going to be an e. We don't know t. We can change it to an x if Chloe wants. And then we do know the rate. The rate is 50%, which as a decimal is going to be
0.5?
0.5. So this is going to be t times 0.5. How do we solve for t? This is a lot harder to do. T is now Rapunzel's trapped up there in that tower. There's only one
Logarithm.
tool that you can use. Rapunzel can only be untrapped by a logarithm.
I wonder, oh yeah, I was gonna ask you, can you use a logarithm?
You're gonna have to. That's why it's in the logarithm unit.
But I got a question too.
Yeah, go for it.
If there's an E, does that mean we also have to do natural?
Oh, he already sees what's gonna happen. He's chosen his base correctly.
That's what natural log means, is it infinite?
Base E. Natural log is base E, and we're gonna use base E because our base in our exponential equation over here is E. Alright, but this is the exponential. You are not. So you are gonna have to move. How are we gonna move 100 to the other side? Alden is on it. I will listen to her words of wisdom. Divide by 100 on both sides. So the way that I'm gonna do zeros, cancel, 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 cancel. I've now only got 4 zeros. I got 3 with 1, 2, 3, 4 zeros. And this side is an e to the power of 0.5 t. Now what?
Or t time.
Now you.
No, it's natural log.
Exponentiate would be what happens if I had a logarithm, but if I'm going, that's kind of like the backwards. If I'm going forwards, I just take the log. Yeah, so I'm gonna take the log of both sides. I'm gonna say, I'm feeling blue. I'm gonna take log of some base with 3 with 1, 2, 3, 4 zeros. I'm gonna take an equal to sign and log with some base of e to the power of 0.5 t. And Diego already said the answer. Again, someone else, tell me my base and why. He didn't say the why, so tell me the base. The base e. Now Alden and I was about to call you Giorgio. Alden and Diego have told me this correctly. It's natural log or base e between the 3 remaining students. Why? Because it's correct.
Wait, so I'm not allowed to answer.
You're not allowed to answer. No. I kind of assumed that you knew the answer, which is why you said it.
Wait, I was
Why,
spacing out for the
why
questions.
did we choose base E? That's correct. We chose base E here and here. Why is that a correct move? I mean,
So it can cancel out big
I'm
E.
sorry.
yeah, you can cancel out
Big
that
E.
other big E, that
Big
base E, because that cancels, that cancels. Only if these two match, and they match. We chose them to match.
So now you got point ST.
So we got, funny. We got all those canceling out, so we got this point ST is equal to, unfortunately over here, it's still, I'm gonna call this thing ln, which is natural log of 3 with a bunch of zeros in there. There's 4 zeros, it's 30,000 times.
30,000.
Log around that.
And then finally, what do? Right now I have 0.5t.
0.5.
Divide by 0.5, or you can
And also
multiply by
equals
2.
1/2. And
multiply-
then
Why would you multiply
it's
two?
times 2,
Oh,
right?
Because it's
Because
the same
0.5
thing.
is the same thing as 1/2, and then that's the same thing as divided by 2, so I can multiply by 2 on both
Oh, okay.
sides. But I think divided by 0.5 is where most people will land, so you'll, I'm running out of colors, I'm going back to black. Divide by 0.5, divide by 0.5, and there's my answer. Let's figure out how long Emma had to wait. T is gonna be equal to, I'm gonna come back
Like,
over
that's
here.
gonna be such a big number.
And it's gonna be, let's type in, how, let's everyone take a guess. What's the natural log of 30,000 divided by 0.5? I'm gonna guess
Somewhere in the
100.
six.
I don't know, what do you guys gonna guess? I have really bad intuition with logarithms. They're crazy. They're crazy slow.
Probably like thousands of years. Probably like 3.5, right?
3.5?
I was
Oh.
just joking.
I was wondering, like, she sounds like she'd use a calculator. Like, she's using decimals over there. It's about 3.259.
It's gonna cost
My
about
calculator.
$13.50.
Is everyone guessing? What's your intuition here?
At least decades.
Yeah, it's got to be decades of I'm here for, right? I'm thinking 100 years. It could be 1,000. I could feel 1,000.
Mike's gonna be dead by then.
All right, so everyone make sure you have your guess out loud
You're
so
gonna
that
be
we
dead,
can't.
sorry.
I wouldn't be able to see it.
2, 3, 4 zeros.
I.
Oh, it was
I
20.
think it's gonna be 10, wait, I think it's gonna be 20.6.
Isn't that crazy? With continuous doesn't exist in the real world. But if it did, Emma, to get from $100 to 3 mil, you only have to wait 20 years.
I was gonna say.
That's not too much.
Oh, I thought
I don't
she
know
was
how you're
gonna be
making
dead by
the
then.
50%, but
Yeah.
like,
It's
20.6.
that's concerning to some extent.
We don't talk about that.
Yeah,
I feel
I
really
should
bad
really round to
for
3 decimal places because that's kind of the default, and I'm not doing the default. So let's come ahead and do
Straight
that.
up at asphalt.
1.6, 1.8, I guess.
618.
And I'm not going to do the fourth type of example, but the fourth type of example, you're solving for R. What was interest rate? You'll know what the starting amount is, you'll know what the ending amount is, and you'll know how long. So there's always 4 different things I can choose. You, or you. Those are the 4 things that can change. One of them you'll have to solve for. If this one you have to solve for, plug this in the calculator. That was example 1. If this one you're trying to solve for, again, plug that in the calculator, bring it over. That was example 2. Example 3 was this one where you're solving for t, but you could also be solving for r, which is the exact same thing. Just remember to convert it to a percent at the very end. That's everything for this lesson in a nutshell. In a nutshell. 3-day lesson in a nutshell. But the last piece I think is probably the most important in terms of making sure you have a good grade, but I want to make sure that you understood too. So I went through that whole rigmarole of all that stuff.
That's scary.
I'm starting to think that I'm actually
All right, so
Yeah.
I know that you might not understand exactly how we got here. There's a very long process that covered multiple days. But just looking at example 1, 2, and 3, how are you feeling on a fist of 5 about these types of problems? I'm seeing, oh God, a 1,
Next attention to 2.
so 12.
12.
1 and 2. I got a 2, I got a 3, I got a 2, I got
I'll
a
put
4
4.
and a 4. All right.
I feel like once I do.
I'm
that,
like a 3.6.